Welcome to Spring LIB.
Okay, so for this problem, we're told we're submersing, immersing a Newtonian ring apparatus in water, and we see that the diameter of the eighth dark ring changes, and we want to get the refractive index of the liquid. So it's the eighth ring. So let's write that down. I think that would be M equals 8. And we know that it goes from a diameter actually, so let's see, let's write it in terms of the radius. So the radius initially, the radius in air is equal to 2.92 centimeters, so 0.029 meters divided by 2, and then afterwards it's 0.0254 divided by 2. And then our goal is to get the index of refraction of the liquid. And we are, so we're told as a hint, we can use the results of problem 33, which tells us that the radius is the square root of m lambda r. So then we can ask the question, why does the radius, why does, the radius of the ring change? Sorry, not the radius of the ring. I guess it would be the radius of the eighth ring. Why does it even change if we immerse it in water? And that's the reason is because lambda changes. So lambda goes to lambda over n. And water has an index of refraction of 1.33. So if we plug in this lambda here, it's just a liquid, so we don't actually know what that is. So that's a question mark. But anyway, as we plug in some new index of refraction, this R is going to decrease by the square root of this n. And so we can say then that R prime equals R divided by the square root of n, just because of the square root, and it's in the denominator because we're doing lambda divided by n. So now we can solve for n. We can say that just algebraically, n equals R over R prime squared. So let's go ahead and evaluate that. Oh, and then we don't even have to worry about the 2's. That's nice. So, and we don't even have to worry about actually changing the units. So we can do 2.9 divided by 2.454 and square it. 2.9, 2.54 and square it. Putting in my favorite calculator, Google Chrome. And so with that I get 1.30. Just make sure, do a sanity check, make sure it goes the right way. So the new radius, I guess it should be smaller because this whole thing is getting smaller because it's being divided by an n, which indeed it does. So great. So that answer makes sense. And I know 1.30 is very similar to the index of refraction of water. Let me just double check that it's the same thing that they get in the book. Didn't make any math errors. Oh, they got 1.32 in the book. Let's make sure I copied all the numbers over correctly. Oh, 2.92. I forgot to write down that too. So there we go. Let's go ahead and change that. Okay, and then I get the 1.32 that I want. So I put that 2 back in. 1.32. Great, even closer to water.